So let's start the lecture again. It's clear that every uniform convergent sequence is pointwise convergent. It's clear that every uniformly convergent sequence is pointwise convergent. Okay, this thing is clear. आपको समझ आ रहा है? Are you getting my point? तो क्योंकि पॉइंट वाइज कन्वर्जेंस में आप पहले x ले रहे हो फॉर ऑल x, तो यहाँ पर आप बाद में ले रहे हो x. But converse is not true. We see we will discuss some examples on that. But converse is not true. Okay. It has a lot of correction in this. So let's see these notes. First note. If a sequence converges pointwise, if a sequence Fn converges pointwise, if a sequence Fn converges pointwise to F, then for all epsilon positive and x belongs to the interval a b. So let me write this as say xi. Okay, xi I the this I have indexed this class by I. Okay, xi. So it's not actually countable. Okay, xi belongs to ab. So the index set is, in fact, index set is here uncountable because the interval is uncountable. We have uncountably many points in this interval. So why I have used index I? The reason is the following: for all epsilon positive and xi in the interval, there exists epsilon. There should exist. Sorry, not epsilon. Epsilon is already there. There exists some natural number. So that natural number जो होगा वो इस I पर डिपेंड होगा. एक्चुअली मैं x भी डायरेक्टली लिख सकता हूँ. फॉर ईच x देयर एग्जिस्ट n x. मैं इसमें सबस्क्रिप्ट x यूज कर सकता हूँ, तो वो थोड़ा awkward लग रहा है. So better to write this: for each xi in the interval ab there exists ni. So then it's understood that this ni, it depends on xi also, and it also depends on epsilon. For all epsilon positive and xi in the interval a there exists ni such that this thing hold: fn xi minus f of xi is less than epsilon for all n greater or equal to ni. अब ये जो सेट है ना, if the set is bounded, जो इंटीजर्स आपको मिल रहे, if this set ni is bounded above, अगर ये bounded above होगा and its supremacy n, अगर इसका सुप्रीम क्या होगा n, then we can write then for all epsilon positive we have this mod of fn x minus f of x. You can easily verify this is less than epsilon for all n greater or equal to n, and for all x in the interval ab. So that means the sequence fn converges uniformly to f. So this means fn converges to f. Let me write here. Let me use this notation here. Okay, uniformly. अब ये जो कैपिटल N होगा ये सिर्फ अब किस पर डिपेंड होगा, एप्सिलॉन पर, ये x पर डिपेंड नहीं होगा, क्योंकि जितने भी एक्सेस के लिए है आपने उनके लिए NI's चूज किया, उनका जो सुप्रीम है वो आपने N लिया, सो दिस N विल वर्क फॉर ईच x नाउ. So this is the first observation. And this, if the set is not bounded above, अगर इस set bounded above नहीं हो गई, जो integers का set होगा, then the sequence is not uniform convergent. Okay, it's not uniformly convergent. So likewise we can define the uniform convergent series. Second definition, a series of functions, a series of functions Fn is said to converge uniformly, is said to converge uniformly if the sequence of its partial sums will converge uniformly. If the sequence Sn of partial sums defined by, it's a definition of partial sum, it's defined by this. Snx means the sum of first n terms of that sequence of functions fkx. This converges uniformly. Converges, अब ये सीक्वेंस की डेफिनेशन आपने ऑलरेडी दी है, कन्वर्जेस यूनिफॉर्मली. Now next we have a Cauchy's criterion for uniform convergence. Cauchy's criterion. Cauchy's criterion for uniform convergence. और ये जो स्टेटमेंट इसने यहाँ पर लिखा है, मुझे मतलब ये किसी अच्छी बुक से देखना पड़ेगा इसका स्टेटमेंट. इसने इसको भी करेक्ट नहीं लिखा है जो मुझे लग रहा है. सो लेट्स राइट इट्स स्टेटमेंट फर्स्ट. Theorem. A sequence of functions a sequence of functions Fn defined on closed interval AB, defined on this interval AB, converges uniformly. Converges uniformly on the same interval if and only if इसने जो लिखा है if and only for each epsilon first and for all x, तो इसमें मुझे डाउट है, for all x बाद में आना चाहिए. If and only for all epsilon positive there exists an integer, n such that mod of fn plus p is subscript है n plus p, right, minus fn of x. This difference is less than epsilon for all n greater or equal to capital N, and this p is greater or equal to 1 and for all x in the interval AB. Okay, so this is the correct statement. Proof. So let's assume that this sequence converges. Let's assume that the sequence Fn converges to F uniformly. Converges to F uniformly. Okay. So okay. So, and let epsilon be a positive number. Let epsilon be any positive number. Now let's apply the definition of uniform convergence. So there exists okay, right. Then there exists we can choose integers m1 and m2 such that mod of f and x minus f of x, this is less than epsilon by 2 for all n greater or equal to m1 okay, and and this thing mod of fn plus px minus f of x, this is also less than epsilon by 2 for all say n greater or equal to say m2. I don't think this second one is important. So I think मुझे ये भी change करना पड़ेगा. इसमें क्या है? So I should write there x to n. Okay. So this okay, there exists n such that fnx minus fx less than epsilon by 2 for all n greater or equal to n. Now let p be greater or equal to 1. Okay. Then this thing. Then mod of fn plus p x minus f of x. This is also less than epsilon by 2 for all n greater or equal to capital N. ये भी true है. अब क्योंकि ये जो इनइक्वालिटी है ना ये ट्रू है हर किसी n के लिए विच इज ग्रेटर और इक्वल टू n, मतलब सबस्क्रिप्ट अगर ग्रेटर और इक्वल टू n होगा, यहाँ पर जो सबस्क्रिप्ट है ना वो n प्लस p है. सो n इज ग्रेटर और इक्वल टू n, दैट मीन्स this n plus p is also greater or equal to n, ये भी greater or equal to n. तो अलग अलग जो इसने लिखा यहाँ पर m1 इसके लिए होगा, so m2 इसके लिए होगा, then he has chosen the maximum of those two, so that's irrelevant actually. So you just apply the definition of uniform convergence. So let epsilon be a positive number, then we can choose an integer n such that this holds fnx minus fx less than epsilon by 2. This is the definition of uniform convergence. Now let p be greater or equal to 1, then this thing will also hold. क्योंकि इसमें कंडीशन क्या है, ये जो सबस्क्रिप्ट है दिस शुड बी ग्रेटर इक्वल टू n, और इसका सबस्क्रिप्ट तो है ही ग्रेटर इक्वल टू कैपिटल N, बिकॉज n इज ग्रेटर इक्वल टू कैपिटल N and p is greater equal to 1, so n plus p is obviously greater or equal to n. So and this is this one, यहाँ पर आपको ये भी लिखना है, for all n greater equal to n and x belongs to the interval AB, ये भी आपको साथ साथ लिखना है, x belongs to the interval AB. Now let's see this. Now let us see this difference जो आपको चाहिए, fn plus p x minus fn of x. We want this to be less than epsilon. Okay, this is equal to fn plus p x minus f of x plus f of x and minus fn x. Now let's apply triangle inequality. This is less or equal to mod of fn plus px minus f of x plus mod of, it's actually fx minus fnx, but you can write it as fnx minus fx under mod, and both are less than epsilon by 2 for all n greater or equal to n. They are, this is less than epsilon by 2 plus epsilon by 2 for all n greater or equal to n, and x belongs to the interval a p. So therefore this difference is less than epsilon. Okay, so this implies mod of fn plus px minus f of x, this thing is less than epsilon for all n greater or equal to capital N, and x belongs to the interval a b. So that proves the necessary part. Now we prove its sufficiency. Okay. So now let's assume that the condition holds. Conversely, assume that for all epsilon positive there exists an integer n such that this holds fn plus px minus fnx, this thing is less than epsilon for all n greater or equal to capital N, and x belongs to the interval a b. Okay, now this fnx, it is actually now Cauchy sequence of real numbers. So from this you can see that this sequence is actually Cauchy sequence. Okay, so Cauchy sequence की definition क्या है, fmx minus fnx less than epsilon for all n greater or equal to capital N. So this is a Cauchy sequence for each x in the interval AB. So therefore
screen visible नहीं है.
Yes, screen is not visible. Screen okay.
म्यूट है क्या?
स्क्रीन नहीं आ रहा आपको? हाँ, हेलो, स्क्रीन विजिबल नहीं है? आपको स्क्रीन नजर आ रहा है इसका? हाँ इत्शम,